Forecasting is the process of making statements about events whose actual outcomes have not yet been observed. A commonplace example might be estimation of some variable of interest at some specified future date. Prediction is a similar, but more general term. Both might refer to formal statistical methods employing time series, cross-sectional or longitudinal data, or alternatively to less formal judgmental methods. Usage can differ between areas of application. For example, in hydrology, the terms forecast and forecasting are sometimes reserved for estimates of values at certain specific future times, while the term prediction is used for more general estimates, such as the number of times floods will occur over a long period. Risk and uncertainty are central to forecasting and prediction. It is generally considered good practice to indicate the degree of uncertainty attaching to forecasts. In any case, the data must be up to date in order for the forecast to be as accurate as possible. Categories of forecasting methods: qualitative versus quantitative methods. Qualitative forecasting techniques are subjective, based on the opinion and judgment of consumers, experts. They are appropriate when past data are not available. They are usually applied to intermediate or long-range decisions. Examples of qualitative forecasting methods are informed opinion and judgment, the Delphi method, market research, and historical life cycle analogy. Quantitative forecasting models are used to forecast future data as a function of past data. They are appropriate when past data are available. These methods are usually applied to short or intermediate range decisions. Examples of quantitative forecasting methods are last period demand, simple and weighted end-period moving averages, simple exponential smoothing, and multiplicative seasonal indexes. Norv approach. Norv forecasts are the most cost-effective forecasting model, and provide a benchmark against which more sophisticated models can be compared. For stationary time series data, this approach says that the forecast for any period equals the historical average. For time series data that are stationary in terms of first differences, the Norv forecast equals the previous period's actual value. Time series methods. Time series methods use historical data as the basis of estimating future outcomes. Moving average, weighted moving average, Kalman filtering, exponential smoothing, autoregressive moving average, autoregressive integrated moving average, for example Box-Jenkins, extrapolation, linear prediction, trend estimation, growth curve, causal/econometric forecasting methods. Some forecasting methods try to identify the underlying factors that might influence the variable that is being forecast. For example, including information about climate patterns might improve the ability of a model to predict umbrella sales. Forecasting models often take account of regular seasonal variations. In addition to climate, such variations can also be due to holidays and customs. For example, one might predict that sales of college football apparel will be higher during the football season than during the off-season. Several informal methods used in causal forecasting do not employ strict algorithms, but instead use the judgment of the forecaster. Some forecasts take account of past relationships between variables. If one variable has, for example, been approximately linearly related to another for a long period of time, it may be appropriate to extrapolate such a relationship into the future, without necessarily understanding the reasons for the relationship. Causal methods include: regression analysis includes a large group of methods for predicting future values of a variable using information about other variables. These methods include both parametric and non-parametric techniques. Autoregressive moving average with exogenous inputs. Quantitative forecasting models are often judged against each other by comparing their in-sample or out-of-sample mean square error, although some researchers have advised against this. Judgmental methods. Judgmental forecasting methods incorporate intuitive judgments, opinions and subjective probability estimates. Composite forecasts, Cook's method, Delphi method, forecast by analogy, scenario building, statistical surveys. Technology forecasting, artificial intelligence methods, artificial neural networks, group method of data handling, support vector machines. Often these are done today by specialized programs loosely labeled data mining, machine learning, pattern recognition, other methods, simulation, prediction market, probabilistic forecasting and ensemble forecasting. Some socio-economic forecasters often try to include a humanist factor. They claim that humans, through deliberate action, can have a profound influence on the future. They argue that it should be regarded a real possibility within our current socio-economic system that its future may be influenced by, to a varying degree, individuals and small groups of individuals. Recent popular publications like Capital in the 21st Century are regarded as major contributors to the increasingly apparent possibility of such reality. It is argued that the influence private and public investment have on our future can never be discomposed of the individual Machiavellian human character. All methods that disregard this factor can not only never accurately predict our socio-economic future, but can even be used as strong coercion tools. Such theories are generally regarded conspiracy theories, but the increasingly worrying socio-economic development in the world grants some of these theories a persistent credibility. Forecasting accuracy. The forecast error is the difference between the actual value and the forecast value for the corresponding period. Where E is the forecast error at period T, Y is the actual value at period T, and F is the forecast for period T. Measures of aggregate error. Business forecasters and practitioners sometimes use different terminology in the industry. They refer to the PMAD as the MAPE, although they compute this as a volume-weighted MAPE. For more information, see Calculating Demand Forecast Accuracy. See also, Calculating Demand Forecast Accuracy, Consensus Forecasts, Forecast Error, Predictability, Prediction Intervals, similar to confidence intervals, Reference class forecasting, seasonality. It is common in many situations such as grocery store or even in a medical exam or a unregistered trademark office, that the demand depends on the day of the week. In such situations, the forecasting procedure calculates the seasonal index of the a 7 seasons, one for each day which is the ratio of the average demand of that season to the average demand across all seasons. An index higher than 1 indicates that demand is higher than average. An index less than 1 indicates that the demand is less than the average. Applications. Climate change and increasing energy prices have led to the use of again forecasting for buildings. This attempts to reduce the energy needed to heat the building, thus reducing the emission of greenhouse gases. Forecasting is used in customer demand planning in everyday business for manufacturing and distribution companies. Forecasting has also been used to predict the development of conflict situations. Forecasters perform research that uses empirical results to gauge the effectiveness of certain forecasting models. However, research has shown that there is little difference between the accuracy of the forecasts of experts knowledgeable in the conflict situation and those by individuals who knew much less. Similarly, experts in some studies argue that role thinking does not contribute to the accuracy of the forecast. The discipline of demand planning, also sometimes referred to as supply chain forecasting, embraces both statistical forecasting and a consensus process. An important, albeit often ignored aspect of forecasting, is the relationship it holds with planning. Forecasting can be described as predicting what the future will look like, whereas planning predicts what the future should look like. There is no single right forecasting method to use. Selection of a method should be based on your objectives and your conditions. A good place to find a method is by visiting a selection tree. An example of a selection tree can be found here. Forecasting has application in many situations. Supply chain management. Forecasting can be used in supply chain management to ensure that the right product is at the right place at the right time. Accurate forecasting will help retailers reduce excess inventory and thus increase profit margin. Studies have shown that extrapolations are the least accurate, while company earnings forecasts are the most reliable. Accurate forecasting will also help them meet consumer demand. Economic forecasting, earthquake prediction, again forecasting, land use forecasting, player and team performance in sports, political forecasting, product forecasting, sales forecasting, technology forecasting, telecommunications forecasting, transport planning and transportation forecasting, weather forecasting, flood forecasting and meteorology. Limitations. Limitations pose barriers beyond which forecasting methods cannot reliably predict. Performance limits of fluid dynamics equations, as proposed by Edward Lawrence in 1963, long-range weather forecasts, those made at a range of 2 weeks or more, are impossible to definitively predict the state of the atmosphere, owing to the chaotic nature of the fluid dynamics equations involved. Extremely small errors in the initial input, such as temperatures and winds, within numerical models double every 5 days. Complexity introduced by the technological singularity. The technological singularity is the theoretical emergence of superintelligence through technological means. Since the capabilities of such intelligence would be difficult for an unaided human mind to comprehend, the technological singularity is seen as an occurrence beyond which events cannot be predicted. Ray Kurzweil predicts the singularity will occur around 2045 while Vernor Vinge predicts it will happen sometime before 2030. See also. References. Armstrong, J. Scott. Principles of Forecasting, a Handbook for Researchers and Practitioners. Norwell, Massachusetts, Kluwer Academic Publishers. ISBN A0-7923-7930-6. Ellis, Kimberly. Production Planning and Inventory Control. McGraw-Hill. ISBN A0-412-03471-9. Gazer, Seymour. Predictive Inference, An Introduction. Chapman and Hall, CRC Press. ISBN A0-390-87106-0. Gilchrist, Warren. Statistical Forecasting. London, John Wiley & Sons. ISBN A0-471-99403-0. Hindman, R.J., Kaya, A.B. Another Look at Measures of Forecast Accuracy, Monash University Note. Makridakis, Spiros. Will Wright, Stephen. Hindman, Rob J. Forecasting, Methods and Applications. New York, John Wiley & Sons. ISBN A0-471-53233-9. Kress, George J. Snyder, John. Forecasting and Market Analysis Techniques, A Practical Approach. Westport, Connecticut, London, Quorum Books. ISBN A0-89930-835-X. Risha, Nicholas. Predicting the Future, An Introduction to the Theory of Forecasting. State University of New York Press. ISBN A0-7914-3553-9. Sasic Kaligazides, and al. Upgraded Weather Forecast Control of Building Heating Systems. PA 951 FF and Research in Building Physics and Building Engineering. Paul Fazio, ISBN 0-415-41675-2. Tassler, R. Climate and Building Energy Management. Energy and Buildings, Volume 15-16, pages 599-608. Turchin, P. Scientific Prediction in Historical Sociology, Ibn Khaldun meets Al-Saud. In History and Mathematics, Historical Dynamics and Development of Complex Societies. Moscow, Kimkniga. ISBN 978-5-484-01002-8, United States Patent 6,098,893. Comfort Control System incorporating weather forecast data and a method for operating such a system, Malakuti, B. Operations and Production Systems with Multiple Objectives. John Wiley & Sons. External links, Forecasting Principles, Evidence-Based Forecasting, International Institute of Forecasters, Introduction to Time Series Analysis, A Practical Guide to Time Series Analysis and Forecasting, Time Series Analysis, Global Forecasting with IFs, Earthquake Electromagnetic Precursor Research.